Okay, so time for an example. Given the graph of f of x, let's find a few different things here. And let's go ahead and start with part A. Find where f is increasing. And so what I'm going to do for this problem, probably after you get used to these, you do a few homework problems, things like that. You probably won't need to do any work to, write down this answer. But what I'm going to do, since this is our first one, I'm just going to go ahead and draw in some arrows along this graph. So I'm looking for increasing. So I want to know, where is this function going up as I look from left to right? And it seems like that starts happening at x equals -3. So I'm going to start drawing some arrows there. Functions going up, up, up. And that seems to stop happening at +3. So my function is increasing everywhere between x equals -3 and x equals +3. Now, do those need to be parentheses? Do those need to be brackets? It really just depends on who you're asking. And MyMathLab will actually accept both. They'll accept it with parentheses, they'll accept it with brackets. And I think parentheses is a little bit more correct of the two, but it doesn't matter. As far as increasing is concerned, parentheses, bracket, nobody really cares. And let's say for part B here, let's go ahead and do decreasing. So part B, find where f is decreasing. And I'll do the same thing with my arrows. I'll put these in blue. So this function is going down everywhere to the left of -3, it looks like. And then also after +3. All right, so let's see here. It starts decreasing all the way to the left, so all the way at -infinity. And it keeps decreasing until it gets to -3. Then it stops. We already saw in part A it started increasing between -3 and +3. And then it starts decreasing again at +3. And it keeps doing that all the way to the right. And all the way to the right on the x-axis there is +infinity. And let's see here, part C, find where f has a local maximum. I'll just say max for short. So find where f has a local maximum. So our definition for local maximum was it's any place where the function is defined and the function changes from increasing to decreasing. Well, it looks like the only place where that happens is over here at +3. At +3, we have that high point on the graph. And so I'm going to go ahead and answer part C as at x equals +3. And now that we have an example in front of us, I kind of want to briefly mention what this word local means. Certainly that point there at 3, 5, that is not the highest point on the graph. We know that graph goes all the way up to +infinity on the y-axis at some point. But local maximum is just asking, locally around the other, or in reference to the other points around it, do we have any high points on the graph of this function? So that's what the word local there means. It's not an absolute maximum, it's just a local maximum. And let's tack on a part D here. What is the local max? And I've heard this asked a couple different ways. So I could ask, what is the local max, as opposed to part C was, where is the local max? So I could ask, what is the local max? I could ask, what is the local max value? Or I could ask, what is the local maxima? So a couple different ways of saying the same thing here, which is typical for math. So local max, and what is the local max, or what is the local max value, or what is the local maxima, all mean the same thing. And what they're specifically asking for here is in part C, we figured out where this high point is. In part D, we want to know, okay, well, how high does that function actually get at that high point? And in this case, that goes up on the y-axis all the way to +5 there. And let's see here, part E, find where f has a local min, or local minimum. And that's gonna be at, so that's any place where the function exists everywhere. The domain here is all real numbers. So it's any place where the function exists and it changes from decreasing to increasing. It looks like that happens at -3. We have that low point on the graph. So it looks like that happens at -3. And then ask a similar question to D for part F. So find what is the local min, or the local min value, or the local minima. Okay, so that's going to be a y value. In this case, that local minimum point there, it has an x value of -3. That was the answer to part E. The answer to part F here is going to be the y value. That is -4 in this case. And that is going to do it for this example.